And I think we may have to switch back to cameras.
Oh yeah, I think. Let me just see. There we go.
Right, so I think we're getting it. It should be coming in now. Yep, that looks like it's working.
All right, great.
Perfect. I think we're definitely getting ready to go. And I will have some people joining us in here in a little bit to make sure everybody is joining on time because I know it's like 7 p.m. for some
Yeah,
people. Yeah, I know it's just like 12 o'clock for us, but they had a whole day.
that's right.
They had a whole day ahead of them, and we just now working our way into it. So
That's right.
all good. And I think we have Kayala joining us. Good afternoon. I saw her coming on LinkedIn there. So I think we're having a lot of people just joining in. So let's give them like a 2 minutes or so because we're gonna be talking about a very interesting topic today, and I know people are excited about it because it's all about Greece, and who wouldn't be excited about that? I know we talk about it quite a bit, so
Yes.
definitely it's something that we would love to talk a lot more about. So we will just wait a little bit to get some people to join in. And for those who are not familiar with ASTM D7718, we're definitely going to give you some more information on that in this session. And Rich is going to guide us for sure on everything we need to know and a little bit more about that standard because we have these standards are in place for a reason, clearly. They are definitely to help us get stuff in the right order, in the right way, to make sure that we're doing it properly. Because if you don't have a standard, then you're just doing whatever you feel, and whatever you feel can work. And sometimes not, that's not always the best thing because we may not always know what to compare it against. So it's definitely always a good thing to have some standards in place.
So
So,
while yes, very good point. While people are joining, I'm going to shut my lights off because it
okay.
might make for a little better transmission here.
All right, that's fine. Save that energy. But definitely standards are very important. They they help us with regulate so many things and make sure that we have a baseline to compare things against. So standards are critical in grease sampling and oil sampling and really in anything else that you do. And that's why we have so many governing bodies that try to regulate how we approach these things and make sure that we have some sort of a baseline. Because, like, if we don't have a baseline, then what I'm doing in my plans is not what you're going to be doing in your plans. And it'll be difficult for people to compare and get results and all of these great things in life. So, standards are very, very important. And Rich will share with us today a couple of things about those standards. I know Hamza just joined us. So, glad to see you, Hamza, always for joining us in. And we know it's 7 p.m. on your side, so we're very lucky to have you with us today. I think we should probably get ready to start because I think we have Miguel as well joining us in from Total Engineer Energies, Technical Service Engineer Total Energies. So he is joining us too. It seems as though the Samba link is not working, but I'm glad that you could join us on the LinkedIn live instead. So that's perfect.
Yeah, great.
Yeah, once we have you with us, we're fine. we are good to go. And this
So
will be recorded as well on YouTube.
yeah, do we think? I guess the folks who tried to join through
Mm-hmm.
Samba realized that wasn't there, and then they went back and
Right.
looked at the other links you had. So we
Yes.
should have most folks here on YouTube or
Or LinkedIn.
LinkedIn
Yeah.
Live. Okay,
Yeah.
so I can get things kicked off then.
Yeah.
Yeah,
Let's get some things
super.
going.
All right. So, you brought up some good points about having standards and kind of a common way of testing that has to include
Mm-hmm.
back to the sampling point. Because if the sample is not
Yep.
consistent, it's not comparable to the other ways that people are taking samples, the data will suffer, the data will
Yeah.
vary. And
Mm-hmm.
of course, when it comes to machinery reliability, we are often focused on trending, right? How
Yep.
are things changing over time? And if we have changing ways in which we're grabbing samples, we'll see changes when there's no changes in the machine.
Mm-hmm.
The really interesting thing that I got a chance to learn from is when I started looking into the wind industry. I got to meet some folks from Denmark, including Dr.
Oh,
Kim Esbensen,
yes.
who is the leading practitioner right now of the theory of sampling.
Oh.
So it's that theory of sampling that kind of underpins how we approach our
Mm-hmm.
methods and develop our standards and so on. So as I talk today about the ASTM standard for in-service grease sampling, know that it comes from an actual field of science, the theory of sampling. And I was thinking about that coming into this presentation today, like how can we relate to it, and knowing that a lot of
Mm-hmm.
our audience, like the title of this audience is the kingdom, and there, that petroleum is a huge industry in that space. I thought about it this way, if someone goes out and they believe that there are reserves of oil in a certain spot, and say they get a shovel out and they dig down so far and they pick up a shovel and it's 50% oil and 50% sand,
Ah.
you would say, is it logical then that the entire desert is 50% oil and 50% sand? No, you
Mm-hmm.
wouldn't guess that will be the case. Your sample is not representative of the
Right.
entire lot. It is a subsample, and there's a very methodical, mathematical, and scientific way to approach the sampling process so that you do get something that is representative. And what Dr. Espenson always goes back to, by the way, there was uh, Dr. G, Pierre G, who developed this technology, and now Dr. Espen is taking it forward. He says that a sample is valid if everything that is in that entire lot has an equal and non-zero probability of being in that sample. So and
Oh.
for example, like when we look at let's say coal, which is kind of
Mm-hmm.
on the decline, right? But we have this whole history of burning coal for warmth and making electricity and so forth. But if we want to test coal for its BTU value, we don't walk up to a giant coal pile and stick a shovel in the
Yeah.
side of it and say, there's the coal.
There's a
What
sample.
we, yeah, what we do is as the coal is being offloaded, and it's on a conveyor, there's a sweeping mechanism that comes through and sweeps a representative piece of the coal.
Right.
And by analyzing that sample, it then has an equal and non-zero probability of being in that sample, so we can do some mathematics on that. So I just wanted to start this discussion by saying
Yeah.
there's a real science
Yeah.
behind all this, and it was I had the chance for that to directly influence what we were able to develop with the Grease Thief and the ASTM standard. So, if you don't mind, Sonia, I'll put
Yeah.
the PowerPoint up here, and we'll
Yes, for
kind of go
sure.
kind of go with that. And I think if I do something like this, can I reverse that? Maybe something like that. How's that?
Ah, that looks good.
Yeah.
I may take my camera off so that they can see parts of the slide because I think I'm hiding parts of the slide.
Okay. Sounds good. All right. And I will just tell you, Sanya, in the background, the little bit of fuzz that I heard there disappeared as soon as you took yourself out. So there might be something on your microphone or whatever, but Certainly, we'll get you back here at the end and talk about it. So let me dive into in-service grease sampling. Today's topic is that deep dive into D7718, and certainly I dove pretty deep right off the bat by talking about the science of the study of this that's behind everything that we talk about. And I think it's important for us to build upon a strong foundation. And that's what the theory of sampling is for us. But let's talk about in-service grease sampling. There has been this historic difficulty in obtaining samples, so much so that I believe it is one of the main barriers to the adoption of grease analysis. If there's a paradigm or a general belief that you really can't get a representative sample, well, then why bother analyzing it? So, and then the other piece to this is that if you look historically at some of the traditional ASTM tests that have been out there for a long time around grease, they require fairly large quantities of grease, things like the cone penetration test, hundreds of grams of grease to get a repeatable value and reliable value. So with those limitations of requiring a lot of grease and not having good ways to get samples, most companies have ignored grease as a data source and then focused on other technologies like vibration analysis or ultrasound or something else. But there have been early adopters doing grease analysis for some time, including the nuclear power industry, where I got my start, airlines, and things like that in response to failures or even just concerns for failures. One of the articles I wrote for a magazine, the Machinery Lubrication magazine published by Noria, talked about a particular airplane accident that was lubrication related, and unfortunately it was catastrophic in nature. But as they recovered the aircraft, as they do with these major failures in the airline industry, they were able to recover the ball screw and the jack that failed, and found the grease in the threads of that. So they were able to extract it and analyze it, and actually found that there was a mixture of greases as well as inadequate greasing per that requirements for there. So it really is something that's happened for a long time, going back decades. There's been grease analysis. I got, like I said, I got involved in the nuclear power industry, but then also some critical fans that were failing at the National Institutes of Health here in the U.S. kind of prompted me to do some initial research to address the kind of sampling limitations that were out there. A little lubrication there. Effective Grease Practices is a publication by EPRI. It talked about and showed us some MOV, or motor operated valve, gearbox sampling and analysis studies. And in previous sessions of this series, I've talked about and put the link out there for this. This is in the general domain, and by going to epri.com and searching for the phrase effective grease practices, this is a publication, a research report that you can download and see how this analysis was done, how it was evaluated, and how it showed the ability to get representative samples from motor operated valve gearboxes. And I bring that up because this is a critical component in petrochemical facilities, as well as certain power plants and certain ship systems. In 2011, this is where I got to meet Dr. Kim Esbenson. Dong Energy and Vattenfall, both companies in the wind turbine space, started a main bearing research project. And then that was followed up with Dong again and Statkraft to evaluate blade bearings. And so two different components with different access, if you will, sizes, different modes of operation, different speeds, and so forth. They each presented different challenges, and there was an opportunity there to establish representative samples by trying different ways and then taking the whole bearing into the shop and opening it up and really painstakingly looking at the grease all around the bearing and see how it changes and is the sample representative and so forth. So coming out of some of those studies, ASTM D7718 was established as the standard for sampling greases from in-service equipment in the 2011 timeframe. That's when it was originally passed. And then it was followed up with some analysis standard as well. And then following these development of these standards, AWEA, which at the time was the American Wind Energy Association, published their recommended practices for grease sampling and analysis with the grease thief. So you have this history of starting at the very basic research levels, of bringing in the science of sampling, and then it being established as the industry standard for sampling in certain industries. ASTM D77 does talk about in-service grease samples. It talks about various types of components. It gives us the requirements for multiple samples. When is one sample good enough? When do I have to take multiple samples? And an example for that might be, let's say, in a marine application where a ship is loading and offloading containers, you're going to have these very large cranes that will rotate, and they'll sit on a large slewing bearing. And they may spend their entire time being loaded only on one certain swing area of that bearing. So if I took a sample on the opposite side or away from where that is moving back and forth, it may not have that information. So there is some discussion in this standard about looking at what are the criteria for one sample is representative or multiple samples should be taken, each analyzed separately. There's a discussion in the standard about passive and active sampling. It talks about the phrase actuate, which is meaning that you take this sample or design and you take core samples. In the past, I think I've talked about being a farmer and taking soil samples. And that's very much a core sampling process where we have a tool that goes down so many inches into the soil, and then we ignore the first inch or two, which is just kind of organic matter lying on top of the ground and rocks and things. And we go into where the root zone is, where the plants are going to be fed, and extract samples from there. And we take multiple samples and we put them together and mix them and then analyze that mixture. And that makes sense in soil analysis. In grease analysis, it might be different. And that's where we have some guidance in here. There's also in this standard some hazards and cautions, some ways in which we can really get samples that we maybe believe are representative, but they're not, and what those kind of interferences could be. And once we're aware of them, then we can design our sampling process, select our sampling tools to avoid those areas of improper results. The standard itself, in the general procedures that are provided, talk about the cleanliness of sampling tools, that you can't basically reuse these tools that are going to touch the surface of the grease from one machine sample to the next, because you can get this carryover or cross-contamination between samples. So we want to have this cleanliness of the sampling tools. We also don't want to have tools that we're going to use and then they sit in a dirty tool bag on their way to the site, and then they get contaminated and it becomes part of the sample. So it's a general principle, and in practical terms, it's addressed in the grease thief kits by all of the tools that come in contact with the grease sample will be sealed in a plastic bag up to the point that the sample is ready to be taken, and that helps with that. There's discussion in this standard about the homogeneity of samples, and grease is kind of notorious for being non-homogeneous or heterogeneous. We know that when we take oil samples, the first thing we do before we analyze them is shake up that sample. We agitate it, we distribute the particles homogeneously through the sample, but we often don't have that opportunity with grease, and the natural distribution is heterogeneous. So that means that the way in which we treat the sample is really important. You go back to that EPRI study, and one of the things I did there was just take a sample as taken and just took a couple of grab samples, as we call them, and analyzed them. And you found that it can vary quite a bit because of the heterogeneity. So there has to be a very deliberate process that meets those requirements of the theory of sampling to get something that's representative. The tools and devices that we use for sampling must be uniform in nature so that they're not varying and changing the way in which we get samples. It's very important that the operator of the sampling equipment be trained and have knowledge of the equipment. The shipping considerations are discussed here, as well as sample labeling, and then the containers and the protective sleeves that need to be there to prevent leakage or co-mixing of samples. Once we get that grease, it may be a grease that has a tendency to bleed as it sits for a while. Well, we don't want it to be able to leak out of our packaging so that by the time it gets to the lab, it's actually lost some of the material, because we want to see what's actually in there in the machine. So sealed up containers are important in that regard. So that's kind of the intro and the overview to the standard. I mentioned the terms passive and active sampling, and so here's a little discussion about active sampling. And this means introducing a device to the surface of or inside of a machine. It means we choose a point in time and say, let's go out there now and sample this. There's a device here called, the device is the Grease Thief Type 2, but it has a feature on it called the Stinger Probe. And that allows for the positioning of the device adjacent to the target surface. So in some sampling challenges, we don't know exactly where that sample needs to go, where it needs to come from, how far into the access opening, let's say. But we can use a Stinger Probe to push it into the reservoir, pushing all the grease out of the way until we get right adjacent to that surface and contact it with the Stinger Probe. And you'll see that in the next slide, what that looks like. That gives us a chance to core that sample adjacent to that moving surface. And that's what we're targeting for these samples. You can use an extending handle to reach a set depth within the machine. That's another way of obtaining an active sample. You can use tubing to extract a sample, possibly from suction, but keep in mind that there's some problems with that I'll circle back to, using the tubing and suction to take a grease sample. Then the last thing is you can use a spatula or some similar soft tool to extract from the accessible surface. In sampling, we want to do no harm to the machine. So we don't want to be digging around with hard tools and jamming screwdrivers into machine parts and so forth. But if we use a soft material like a plastic, a bendable, pliable spatula, then we can get samples from the face of a pillow block or off the surface of an open gear. Here's a few pictures of some active sampling. In the lower left, you can see that Stinger Probe. Lower right, I should say. You can see the Stinger Probe kind of pushing out the bottom of that Grease Thief as it's grabbing a blue grease sample and coring from the surface of that particular pinion gear. Above that, you've got a big pillow block, which is from a large wind turbine bearing, and you're grabbing the grease with the soft spatula as it is extruded or purged when new grease is added. Now, finally, down on the lower left, this is from a bearing manufacturer called Rothe Erde in Germany. So they make these slewing bearings, and they have kind of advertised or put some materials out there about pulling a sample with a syringe. I have to say that this only is effective if the grease is very soft, very low NLGI grade, and very pliable. And even if you have a grease that when it's new is very soft and pliable, it may become harder and stiffer in service. And so if you just rely on that suction to pull that sample out, you may end up with the bled oil only and not the full grease, which includes the thickener, and you're going to get misleading results. So you'll see me circle back to the risks that are there from using suction to get a sample. The passive sampling is where we're going to kind of attach the sampler to the machine. Maybe it's threaded or in some way, like I have a picture here of an electric motor end bell with the bearing housing, and that bearing plug has been removed, and we've threaded a Grease Thief right into that, because it does have a thread that in metric is very close to M10, a metric M10 thread, which we find on a lot of equipment drains. In imperial units, it's a 1/8 inch NPT thread, but it'll thread right into that space and stay there. And that way, when we add new grease, it's not always immediately that the grease is purging out. It may take some time. We add new grease, it heats up, it expands, it pushes the old grease down and so forth. And eventually, and maybe it's 20 minutes later, a half hour later, maybe almost an hour later, then the grease is working its way out through that drain, and you may not be there. So something like this is passive in that it can be installed, stay there, and capture the grease as it comes out. Don't let it fall on the floor or run down the side of the machine, because that's contaminating that sample. Now, those plugs, those openings, typically are meant for purging. If someone's following the instructions, they'll get some notice that, hey, before you grease, remove the plug and leave it out, add the new grease, and then allow it to purge, and then put the plug back in. So there is this purge function in many designs, and if we're going to put a device on there, it also has to have that ability to purge the excess grease. So in this case, the grease thief for the electric motor kits does have a tested 1 to 5 psi relief setting when that piston will move down. And if it completely fills, it can then purge out through the holes. And so that helps us avoid over greasing. So the sample in this way prevents contamination from the surroundings during purge, gives us a chance to get a sample of the most recent grease to leave that housing and tell the story of what its condition is. Now, some folks, their first encounter with grease analysis is through failure analysis, right? We have a critical component that's grease lubricated, and unexpectedly it fails. And what happens then? Well, a process. We're pointing around looking for somebody to blame or what have you. In an advanced maintenance program, then you would initiate a failure analysis. And the failure analysis is not to assign blame, but to find what caused it. And so grease analysis can be a really important component of failure analysis. Too often I see people have a recurring grease lubricated bearing failures, and they pull the bearings out, they put them into a parts washer, they wash all the grease away, they look at it and say, oh, I see some scratches here, and then they send it to a metallurgist to see what they say about it. And what you've done is you've washed away some of the vital information about root cause failure that is in the grease. Was it the right grease? Was it a mixture of greases? Had the grease aged significantly so that the grease replenishment frequency was inadequate for the application? You can ask all these kind of questions. What about contaminants? Maybe you see scratches on the bearing, but you don't know what that came from. You just know something caused some scratches. Well, if you have the grease sample and you analyze it, you may find specific particles, and they may be related to a process that is going on in your facility. I think I shared a story about some failures where we were asked to do root cause failure analysis, and the lubricant manufacturer was involved in that process, and they sent us the samples to test it, and we found it full of gear wear, and it wasn't even from a gearbox. And it turns out it goes all the way back to the manufacturing process of the grease, when the pump, the transfer pump for packaging was failing, and it was putting gear particles in all of the new greases. So you do have this as a possible contribution, and all these things you want to get a grease sample for, and correlate that to the observed conditions, the history that's there, the metallurgy that we find from analyzing the parts themselves, but add in that grease analysis to failure analysis. Cautions and concerns. I told you that it's part of this standard, and there's a section for this, and it does say that the use of plastic tubing may not properly suction all of the representative grease. If we don't have a way of fixing the location of a suction tube that's placed into a grease reservoir, the point of sampling may vary, just like is in an oil drop tube sampling. And Sonia, we know from oil drop tube sampling that you can't just let that thing float around inside. You can't let it suck particles off of the bottom. You got to be careful you don't get it wrapped around a shaft and so forth. We know it's a risky type of sampling. And we should really be treating grease analysis the same way if that's our way of taking a sample. So we have to be very careful about that, because the samples must be taken from the live zone in the machine. And that means we have to understand the flow dynamics. Where is the grease moving? What parts are moving? What's dragging the grease around? And often in a reservoir, you might have 80% of the grease just sitting there and standing by. It'll feed in when the other grease is consumed. It will help to transfer oil in grease that has started to dry out, but it's not active. It's not moving around with the part, with the bearing, with the cage. And so the knowing those flow dynamics is really important to targeting the zone within the bearing that is this live zone that we truly need. The sample that we take must be properly labeled and protected during shipment. Remember, we said about having a container that if it starts to leak out, remember, greases can bleed. And like when we first sample it, we're like, oh, it's just like this solid type stuff. It's in pretty good shape. But then it gets transferred, or it's sitting on a truck and it's vibrating. And those kind of movements can cause the shear, can cause oil to separate. And if we don't have a leak-tight container around the sampling device, we may dry out the sample on its way to the lab. And now we're reacting to things that aren't really in the machine. They're just a product of poor sampling. Finally, the sample quantity that we take must be sufficient for the required tests. And the required tests should be selected so that the quantity is not excessive. If I have a bearing that only has 3-4 grams of active grease at any one given time, I'm going to pull some, and then I've got a lab that says we're going to need 20 grams of grease or 15 grams of grease. I'm going to pull what's there, and then I'm going to add new grease until I can get more coming out. And now I actually have a mixture of new and old grease, which makes it look much better than it really is. So the quantity is really important. Smaller bearings with smaller amounts of grease, or I should say, it doesn't really matter on the size of the bearing, but situations where the amount of live zone grease is small. It could be a big bearing with all pounds of grease or kilos of grease in there, but there's only a small area of it that actually is in that live zone. Then we have to choose required tests that can accept a sample of a smaller volume size. Otherwise, we're going to get a diluted and not representative sample. When that sample gets to the lab, then we're going to be looking at some kind of internal label or barcode to follow that process through. It's going to tell us what tests need to be performed, what's the time frame of completion for that particular customer or what have you. What is the equipment? What is the sample baseline? Where on that equipment is the sample from? And who took the sample and who do we contact if something unusual is seen? Because you often, the labeling might be confusing or there's something really unexpected. And to be able to put the person who took the sample in there, that's really valuable because now it's teamwork. It's a team that's now looking at what was found, asking questions, better understanding the equipment and so forth. And that's who's, contributing to the analysis at that point. So we know from some of our previous discussions that the standard for analysis does list 6 tests for that 1 gram of grease. And that really helps us get to that point where we can focus on smaller volume requirements of the sample to get a very nice varied test slate that gives us insight into a lot of different conditions like the wear levels, the consistency changes in the grease, is it hardening or softening, the contaminants that are present, and also that oxidation profile. I've done a number of presentations in the past few weeks at different conferences. Sani and I were talking just before this about my recent visit to Spain, where I did a presentation again. And in this, we end up talking about, the different tests that are available and the quantities of grease that are required and so forth. I'm going to, just kind of put this out there, but I'm also going to show you some developments that we've had that we've been sharing for folks on the sampling side as well as the analysis side. So there's, this standard is out there. It was renewed back in 2019. There's a ASTM working group to kind of address enhancements and improvements to method for some future ballot change. So it's like every 5 years, you've got to do a ballot change. So we're coming up to that. So we want this to be changed to reflect the practices. And so what I would do is I would encourage anyone who has experience in this space to volunteer, to reach out to me, to be a part of the working group that's going to influence the next revision to this standard. For example, if you're out there and you heard a bunch of new stuff today that I'm talking about, and that doesn't reflect your current process, you may want to come back with some lessons that you have, some experiences that you have, maybe in a certain application where a different approach has proven to be quite effective. And we'd like to hear that. We'd like to listen and incorporate what we can into this standard to make sure that it does reflect the practices that are out there. So I finish up here by saying about the new tools and methods that are under development. And what I want to do now is pivot to a fragment of a presentation, which does, Sanya, come from last week, where I had the honor of presenting or co-presenting with my daughter, Abigail, who works for Mantech. That's a manufacturing support organization in our part of Pennsylvania in the U.S., and she's out there every day talking to manufacturers on some of their challenges, what some of the tools that they need to help them do their job better. And so there was this kind of overlap for Abby and I on some of the approaches that she has and some of the things that we're seeing from grease analysis. And she's part of her group there focuses on continuous improvement. And a lot of us have heard about that principle. So what we did for this presentation was kind of focused on how would you apply continuous improvement to be able to enhance the grease analysis process. So we looked at that, and she kind of said there's a few things that we need to do here that are consistent with continuous improvement principles. One is identify the gaps, right? If there's new sampling challenges that are not addressed by this ASTM standard or the current tools, then we want to develop new solutions and put them back into that standard so that they're reflected in the new revisions. And that's what we just talked about. So identifying the gaps. Another is reducing waste. We want to be pursuing new options in grease sampling that reduce single-use plastics, but still allow us to pursue representative grease samples. And so there's some examples of that I'll share. And then reduce required resources. How do we leverage technology to reduce the inputs, the costs, the labor required to still achieve that accurate analysis? So within these three principles of identifying the gaps and reducing waste and reducing required inputs, how does that feed back into the process of grease sampling and analysis? So the first thing that I've mentioned, I believe, in some previous presentations, but I'll bring it up again because we always have new people joining us, and that is the grease thief pickpocket. So it's an advancement of the design here that we've had for some time called the Grease Thief Slim. And the Grease Thief Slim can fit into smaller openings down to 8 millimeters in diameter, and which was a great advancement from the original Grease Thief because that requires something like 13 is it 13? Yeah, something around 13 millimeters of clearance. So you need a bigger hole or a bigger opening to get in. And so this is much less than that. But then the other challenge here was, well, then how do you handle that sample that you get? And sometimes we're able to transfer it from that tube to a grease thief, which is good. In other cases, it'd be like, I would really rather just have a very simple, small tool that I can analyze, like just some basic parameters, like maybe has the color changed and is there a lot of wear debris in it? And so now we've changed that pickpocket, changed that Grease Thief Slim to this pickpocket design, which it has a separable section. And I don't know, Sanya, can you see my cursor over top of this moving around? No. So is in this tool that we're working with now, is there like a pointer or something I can use? I don't know. We're not sure. We'll have to get better at that as time goes on and figure out how we do that. But if you look at this drawing, this representation of the Grease Thief pickpocket, if you look to the upper right or the far right of the drawing, you'll see a circled section and a separation, like a gap between them. And that's showing you how this functions. It's going to core the sample, but then there's an ejection mode for it. Kind of like those of us who've worked in a lab, you've got little pipettes and you can pipette a volume and then your pipette's dirty, so you push the button down and it kicks it off and it goes into the waste bin. This is happening in a similar way. So there's a piston in there because we always need that changing volume to core a sample. Because grease needs to displace the air that's in there. You can't, not just pouring a liquid in, the grease has to go in, and the air would kind of prevent that. So it has that moving piston here, but that piston finishes up right at the end of that short tube section, which is, say it's 2 inches. So that's going to be about 5 centimeters, a little over 5 centimeters long, that this section will be. And that's going to be full of grease, and it's going to be a 1 gram sample. So you get this separate section that you can then eject right into a vial. Remember, we said you have to put in a protective container. And for, easy step, low cost, you now have precise sampling that still meets the ideas of ASTM D7718, but maybe a lower cost approach to taking grease samples. And then what's really exciting for me is that maybe you do just those 1 or 2 easy screening tests like color and ferrous content with the FerroQ. But now you find something, maybe 1 out of 10 samples, you want to find out something more. Well, you still have the piston in that piece, and you can easily transfer that into a full grease thief and do the full test slate that's available for grease analysis. So really, the part of the gaps here were there wasn't really a way to get a precise sampling with a lower cost format, and we've addressed that gap with this. And then also reducing waste, because the plastic used each time is much smaller. It's 1/3 of the total plastic. So we've reduced the plastic consumption there by over 60%. So we've met those 2 goals of continuous improvement. Another way to reduce waste and really also improve the sampling process is by this grease thief filler. It's a new design we have that's taken the place of a standard syringe. And I will say, out of all the negatives that came from COVID, one of the positives for us is it became hard for us to get our hands on syringes, which were very inexpensive, and very very easy to compile into a kit like this. But we were wasting a lot of plastic. We were using a large, say, 5 to 10 milliliter syringe, but only taking 1 gram of grease. Some of it was getting caught in the nozzle. So we've recently designed this device which threads right onto the end of the grease thief. There's a little piston that comes out, and then I use that cup and I load the grease in there. So this is the pillow block kit, and we use the syringe to kind of gather the grease off of the surface of the machine, and then we can kind of scrape that into the cup area and push the piston down, and it does over 90%, close to 95% of the grease is quantitatively transferred into the grease thief itself. So that's really helpful for us. The other thing is that it's much smaller than this large syringe, and so we've reduced the plastic waste by 65% by going to this method. So it's a better way to take a sample. It transfers better. It's probably easier to use in the field. I will say it is easier to use in the field by this design. And then it's also reducing plastic waste. And so, we can stand behind grease analysis as a waste reduction technology, even though there's some single-use plastics involved. Think about how much we're saving from wasted grease, wasting pumping petroleum products out of the ground, if we can make a significant reduction in the amount of grease that we need to use with our machinery, because we're using grease analysis to target optimization. We've talked about optimization in past events, but this gets us there, and it also reduces the waste. I'm going to share one more thing here for you, not directly related to sampling. And wow, there's some kind of strange picture in the middle. I don't know what that was substituting for, but I guess in uploading it to this format, it substituted some kind of crazy picture in the middle. But here we have something we call the Grease Monkey. It's a cobot or a collaborative robot that sits on a mobile stand and allows this to be programmed to do some of the screening tests that we've talked about. And so it allows continuous and really autonomous analysis of grease samples in two of the grease thief formats. It tests the ferro-Q, so we get the ferrous levels, and also the color changes relative to the new grease. So we can see if the color has changed substantially. There's numerical outputs, so we can build criteria around that. It's not subjective. We can say, more than 1,000 ppm iron or 5,000 ppm, depends on the application. Put that threshold in there. Put in what's considered normal, what's considered abnormal, set them aside for further action. The same with the colorimetry, which uses the delta E values that we might recognize from MPC testing for varnishes, of which Sonia, of course, is very familiar with that. She's a bit of an industry expert on that, has even written a book on varnish. But we know that one of the ways that we attack it is to quantify it, to know what's there or what has the potential of showing up, and that's that MPC test. But we're taking that same color kind of color spectrum evaluation quantity and using that to flag grease samples. And then all these are calculated, data goes into the cloud, and it's very much autonomous. We have one of these running in the dark in our laboratory after everyone goes home, continuing to process grease samples. So you can imagine if we can get the sampling process first accurate, because that's important, right? It doesn't make sense to analyze samples where you haven't done the hard work to ensure that they're representative. It's just a waste of time. And some people might say, well, you're a laboratory, you'll analyze anything. And to be honest, I really don't want to. I've said this before, that I don't want to waste your money and my time analyzing samples that are wrong. Instead, they got to be right. And we have to work together to have the tools and the knowledge to get those correct samples. But if we do, we can screen through a lot of them with this automation process. And that really gets us to where we're a low cost of evaluation, and then we can invest on those samples where we know we've got something going on because we're confident we got a good sample. And then we did the analysis, the screening tests to tell us that there's something here that we need to look into further to know what level of priority, what level of action, and what the risk is to the reliability of that component. So that really kind of finishes up what I had on the presentation side. I did have one more thing to share here. And where is it? It's actually the standard itself. And so it's very big pages of very small print. But if it were clear, you could see that it's got, the scope here, the references, the terminology. They kind of kick that off into your standard ASTM format. Just giving you a sense of the layout of it. It's really all the things that I've talked about here. What is the significance and use of this standard? What are the apparatus that I use? How do I record that? What are some of the general sampling procedures, limitations and considerations, right? I said, we talked about the warnings that are there, how you can take a bad sample. So they're there here by step. And I think this standard could be of value, even if, like, say you're doing some grease analysis now and you say, I want to do a better job. Maybe I, want to use the grease thief instead of a popsicle stick or, whatever I found lying around, a screwdriver or something. But the people that are in position to make that decision say, hey, it's good enough. Well, you can come right back to this standard and do a self-evaluation. Look at your process and say, am I up against any of these concerns, any of these limitations, any of these error-producing values? Because if they are, I have to avoid that. Otherwise, I'm throwing away money on grease analysis by taking improper samples or samples that could be problematic. And that's what we have in this standard. And so then there's about sample handling that we talked about. And then the active sampling is we talk about first. That's where we're kind of going in, we're coring the sample, we're kind of scraping it off the surface with a pillow block kit, those kind of active samples that you're grabbing. Maybe you're using the Stinger probe. There's a picture I talked about before, the Stinger probe sticking out the front of the grease thief. It allows me to put that into the machine and feel that I've actually touched the surface of the gear, the face of the gear, or the face of the bearing, and then core the sample right next to it. Because I don't want the grease that's back over here just as backup grease. I want the live zone, the active zone. And that's what this active sampling with the Stinger probe allows me to do. Or I use a tool that allows a fixed depth sampling. That's the other active sampling, fixed depth sampling, where I know the machine, I understand the dimensions, I know where the access point is, and then I set up this T handle to go into the space that far with the piston closing it off, and then core the sample. So that's there. The passive sampling is here as well. It shows the other type of grease thief that doesn't have the Stinger probe on it. And it talks about ways in which you would take a passive sample. Allow the sample to come to you is one way of thinking of it. And that may be the best option in many, many circumstances. And then it gives you actual procedures for sampling from failed grease lubricated components. So this section 11 here, is really the root cause failure analysis component of ASTM D7718. So if you are involved in root cause failure analysis, seriously consider getting a copy of the standard so you can look at section 11 specifically and ensure that you're taking the steps necessary. It tells you, like, when is one sample going to be good enough, or when do I have to take multiple samples? Do I take those multiple samples and mix them all together, or do I keep them separate and analyze each one and then bring the data together to see the bigger picture? It's all outlined here in the standard. And so there's really some value here in doing so. And then it just kind of finishes up with all the notes that are there and so forth. I'd love just to hand them out to you, but there is ASTM does have copyright on these materials. And but I'll share with you a trick. And the trick is this. The standards get pretty expensive pretty quick. I think they cost somewhere in the US like $60 to $80 a standard. But if you join ASTM, it's only $75. And with that, you can get a whole volume of standards. So you get to pick and choose. And what I would say is join for $75, choose the volume that encompasses 7718 and 7918. And now you've got those standards plus probably 50, 60, 70 other standards that could be interesting as well. And then another trick that I do, since we're in this business and I've got multiple employees, I actually pay for membership for 5 of my employees. And each one gets a different section of the ASTM standards, and we've got it covered from one end to the other. So just one way to get there, and being economical about it makes some sense. So you may want to join for that purpose. But again, if you're doing root cause failure analysis, there's value there. If you're an asset owner, you're operating grease lubricated components that have some criticality. Now, you may have something that fails to say, we'll just get another one, we'll toss it away. That's not what we're talking about here. But there are critical components that are grease lubricated. Some of them are motors driving your critical components, and those motor bearings are grease lubricated. It might be a motor operated valve gearbox. It could be a fan, it could be a critical fan. That's where we go, that's where we start. And what I've done today is just to help you make sure that the money and the effort and the time that you spend to understand what's happening in those grease lubricated components has to start with the proper sample. And the proper sample is driven. The instructions book for getting that proper sample is the ASTM standard D7718. So Sonia, I'll welcome you back into the group here. And
All right.
see, you've been watching if there were questions. I've been focused on presenting.
That's
So
okay.
yeah, so let me know if there's any good comments we saw or questions that we can
We
help with.
had a lot of good comments. I mean, of course, that trick that you gave us at the end was very helpful. I will think about that as well because it's always good to be part of these groups and to learn more information and be on the forefront of what's happening because sometimes you can miss that if you're not part of the group and getting the information. So I think that's a really good thing that we should do. And I encourage people to join that group because it's a very active group. And, you have people like Rich in the group. So obviously it's a good choice. We had some questions about, people talking about some of the things that, it was very good information. A lot of times they were asking about, some of the samples because sometimes the technician thinks that getting more of the sample is a little bit better, but that's not always the case because we know too much sample could deprive your actual component of grease. So having the right amount of sample is very important, and being able to assess how much you really need. I think that's one of the critical things, and they talked
Right.
about that in the standard as well. Yeah,
It does, and
yeah,
there's some labs that are taking different approaches to grease analysis, and that's okay. Some will send out their standard oil bottle and
yes,
say, put your grease sample in here. Now, to the person, to the technician taking the sample, you know, they might try to fill that bottle, and
yes,
that could be hundreds of grams of grease. And by doing so, you just keep digging and digging and digging, or adding grease until you get that volume. And that's why we wanted to target 1 gram. And if you fill
right.
a grease thief, you got, I think if you're perfect at it, if you're really experienced and perfect at it, you can get about 1.4 grams of grease into a grease thief.
Wow.
So it does give you a really good target on how much you should be getting. So I don't want 2 grams or 3 grams or 4 grams,
Hmm.
because I want the best 1 gram that
Right.
represents what's happening in that machine. And so having a sample container that you're getting it into that has the target volume really helps in limiting the sampling process to just the amount that's needed. And it's then less likely to have extraneous grease that doesn't tell the story.
Oh boy, because we have Hamza is actually asking a very good question about if the standard mentions how soon should you send the sample to the lab for analysis. And I know
It
that's
does, yeah.
a big
The
one.
so and both Hamza and Sanya probably know that the answer to a lot of these questions are it depends,
Yeah.
right? So it doesn't give you kind of a like it must be so many minutes or hours or days or weeks or anything like that. It talks about what can happen if there are
Mm,
delays between the time that the sample is taken and the laboratory gets to analyze it. So one of the things that can happen is that you can have separation,
right.
and it can be difficult in the lab then to kind of treat that separation in a meaningful way. So you open up the container and you've got some solid material and you've got a puddle of oil sitting here. The more that separation takes place, the more um, challenging it's going to be in the lab to analyze that in a meaningful way. Um, but it's not just time. It's also like how long it sits and how it vibrates, and the
Yep.
shear forces that are put on it, the temperatures that it's subjected to as it's being shipped. So I think what we have found is that if people are prudent and they get the sample into the container, they get it sealed up into the shipping container, and then move it in a kind of reliable time. It could be a week later or 2 weeks later, and probably your grease is going to be okay. I think the exception to that would be grease that's operating in a very kind of caustic or acidic environment
Right.
where you've got these extraneous contaminants, and if the more time you keep them in contact with the grease, the more they can kind of get in there and oxidize things and actually change things chemically from what they were. So I think if we ship in a nice tight container, we don't subject it to temperature extremes or violent vibration. A week, 2 weeks, 3 weeks later, my experience is that sample's probably pretty good and ready to go.
Right.
But much longer than that, we really have to be concerned. And in those situations where we have contaminants that are chemically active in nature, that time shrinks down substantially. And so we'd want to get on that much quicker.
Oh, yeah, for sure. Because I know Hamza was just kind of following up in terms of when you take a sample, especially in the kingdom, and sending it back to the US, in terms of, doing the lab overseas, how does that impact? And I know Ahmed had a question about how quickly do we get the analysis reports, like from the time of like receiving the grease in the lab to actually getting the results on what's going on. So those are
Yeah.
some questions coming in, very important questions as well.
Sure it is. And each lab is going to have their own
Yep.
process and so forth. Some labs might have like an expedite fee where you can get that, where you can
Ah,
get kind of moved up in the queue, get things a little more quickly.
Mm-hmm.
Our standard response time is within 5 business days. For example, at our lab,
Mm-hmm.
other labs it may be a little bit different. Um, but what I would say is that it depends on the testing that's being done as well. Because if
Yes.
you're just doing the screening test, and you saw the robot that I
Mm-hmm.
showed there, the
Yeah.
grease monkey, it's actually producing data within minutes of the sample arriving at the lab. And so, in that way, if an active and engaged asset owner is checking that or getting notifications, it could
Right.
be almost as soon as it gets to the lab. If it's
Mm-hmm.
something more detailed, if it's we're doing analytical ferrography or some of the other
Mm-hmm.
tests that take more time, then that's going to slow that down as
Right.
well. But I think the answer is it varies, but
Yes.
we should want to get the results in a fairly quick turnaround time so we can make those important decisions.
Oh yeah, I and definitely you always have to sort of have a bit of a buffer when you're taking these samples. So, don't take your samples after the equipment, you're just about ready to change stuff. Make sure you have some time in between so you can check the health, get back your results on time. Make sure that you have things that are coming in terms of being able to make those decisions on your assets. Because if you don't, then it's almost as good as not sending a sample off at all, when you think about it.
Yeah, I have an extreme example where
Oh,
uh, it was in a pharmaceutical manufacturing facility, and we got this sample, and all the metals in it were like highly oxidized and stuff. And I was like, all it had was the equipment name on it. So I called him back and I said, "When was the sample taken?" And he said, "Oh, I don't know. It's probably been 2 or 3 years. It's been sitting in my desk drawer." I'm like, "What exactly do you want us to test, and what are you going to do with that data?" So
yes.
it's kind of an extreme example, but no, things have to be done in a timely manner. I think one thing to think about though is that grease tends to keep everything in stasis.
Mm-hmm.
It's suspended. It's kind of has this protective layer around it. Whereas oil, things can settle out. They can stuck to the
Right.
inside of the bottle.
Mm-hmm.
There's easier for chemical kind of actions to take place in oil where they can kind of move around in the fluid more readily than they can in the grease. So I would say we get a little bit of a relief from
Yeah.
the how quickly we have to do things when it comes to grease versus some of the oils. But again, it does depend on the circumstance of the sample.
Oh, yeah, for sure. And I know Hamza is just asking about, apart from MRG's US lab, is there another lab in the world that can actually conduct the extensive tests on grease samples via the grease teeth?
Yeah, it's a great
So,
question. There are seven. And one of them, the folks from that lab were recently. Um, there was a conference a month or two ago in the Middle East. I can't remember. I don't think that was in Saudi Arabia. Do you remember, Sanya, where
I
that
don't
was?
remember exactly where it was, but I
Yeah.
do know what you're talking about.
Yeah. Well, anyway, these folks are from Poland, and
Right.
so they're kind of in almost the same time zone or whatever.
Mm.
But they've been active in reaching out to folks in the Middle East, and they have the grease thief analyzer in their lab in Poland. Uh, Further west in Spain, I just last week I saw the grease thief analyzer at Bureau Veritas in Spain. So there's one there. They're a little further away in Shanghai. Running Land Labs has one there. And then we have a number of them in North America. It's something that I want to hopefully can see continue to expand. I'd love to see some instruments make their way into the Middle East, specifically
Mhm.
the Kingdom of Saudi Arabia, and hopefully the work that we're doing here together, Sanya, with Hamza, builds the interest, the demand for that, and we'll see it expand. What I've said is all it takes is for X number of customers to go to a
Mhm.
laboratory and say, I want to send you this many samples, and I'd like them analyzed by D7918. Then we have no choice but to get things set up there. So hopefully that's how this plays
Yes.
out.
Yes, definitely. Because I know our friends out in KSA, we need to have the information and we need to be able to get that information from the grace, be able to find out what's going on. We need to be able to have access to that. So I know that Hamza is saying if we could share some of the info on the testing labs, we will share some of that info on LinkedIn in a little bit, and through the emails as well. So just making sure that everybody gets the information that they need, because at the end of the day, we're trying to protect your components. We're trying to make sure you don't have those unplanned shutdowns, and that you can actually get the value out of your assets by monitoring what's going on with your grease. And I think that's one of the best ways to do it. Make sure that you know what is happening. So I know we are a little bit out of time, coming down to our end of our session. But Rich, I want to thank you so much for your time and for sharing your expertise, and for everybody that joined us, because I know we're dealing with a lot of different time zones. So very grateful for everybody who took the time out of their day to join us today. I will probably send out an email in a while with the recording and possibly some other links. So look out for that, and look out for our next session in July. Yeah.
Great. Thanks to everybody that participated, all the good questions we have.
Yes.
Thank you, Hamza, for your leadership and continuing to work with us on this. And we'll see everybody
Definitely.
next month.
All right. Bye.
All right. Bye now.